So I think we'll forge ahead here. And I'm going to turn it over to Andy Thode to give us a little bit of background on the overall project and today's effort.
So I don't want to spend too long on this, but everyone should have received a little two-sided, one-page handout about this webinar and about the project in general that has some more detail. But Southwest FireCLIME is funded by the Joint Fire Science Program. The original call for proposals on this one was not to create a bunch of new modeling related to climate. It was to really integrate management strategies into existing climate models and fire climate models, and to figure out what management strategies may have some quote-unquote bang for the buck in the future. And so that's what we're trying to look at here, is ecological bang for the buck, as well as just overall what are our effects with different management into the future with climate change. So it's meant to be a very strong partnership between managers and scientists, which we are very happy to have folks on the call today to hear what we're up to. The core team for this is actually very large. As you heard, quite a few people on the call are involved in that team, and it's a mix of managers and scientists from around the Southwest. Really, we want to test these new management scenarios, and then at the end provide some guidelines for managing these regional resources under a changing climate. Now hopefully, oh, is there a delay for everyone, or did everyone see that switch pretty quick?
Pretty quick.
Good. All right, we had a big delay when we practiced. So I don't want to get in too much detail about our process, but there is a four-phase process to this project. The first was a science synthesis where we put on a workshop in Albuquerque in September of 2016, and we pulled together all the literature that we could find on fire and climate effects in the Southwest, and that sort of started off this project. Then we moved into the modeling and scenario building piece, which is what you are on this call today for. And the idea is that this is a reiterative process where our modelers have put together some scenarios, and then they have modeled those. We're trying to get feedback from you all and then figure out what we should be modeling next that would actually be helpful to everyone on the ground. And then after that, our phase 4 is a joint interpretation and synthesis. So the idea is to get folks together in a final workshop about this. Hopefully people that participate in these webinars will be involved in that, to be able to come up with these guidelines for the future that are created both by managers and scientists together. So the goal of this webinar, again, is to present these modeling results, get the feedback on these results, develop new management scenarios to model. So we're going to talk at you for a little bit, but then we really need your participation and you to talk at the end to tell us what your thoughts are about what we're doing, what's crazy, what might work, and where we want to go in the future with new scenarios. I just want to introduce some terminology really quickly that we're going to probably use throughout this webinar. These are sort of little names that we've come up with temporarily for getting us through this. And the first is business as usual. So this is what we tried to model for this webinar to get feedback on, and it reflects current management practices, either from actual treatments that have been done on the ground and data collected through the FACTS database, or also through the EIS for the Jemez. The stretching the box scenarios are meant to extend current management practices, even though funding may not support them or other factors. The beauty of modeling is that you can explore things risk-free. And so we want to try and do that. We did model one stretching the box, which is basically just creating more area of treatment on the ground than we have in our business as usual, but we do want to expand and think about that. And then the out-of-box scenario is really moving towards new and novel ideas of things that we could do on the ground. They may not have social and political backing at this point. They may not have funding at this point, but at least to think about what we could try on the landscape that possibly could make a difference in the future. So those are our three sorts of categories of treatments that we'd like to think about. So with that, I'm going to go ahead and pass it on to Will. And we can handle questions as we go through, right?
Yeah, that's fine. You feel free to ask questions. The line is open. Sometimes I'll mute the line, but I think everybody seems to have quiet background noise, so we'll leave the line open. And you can also type questions if you feel like you don't want to interrupt the flow of things. And certainly if there's a technical issue, please put it in the chat window, and I will try to address that while the speakers continue. And I believe Rachel is going to kind of give us a quick overview of the modeling.
My bad.
Yeah, okay. Sorry, not Will, just Rachel. Okay, yeah, I'm going to talk really briefly about the way, about the models we used and what we did with them. And there'll be time later, possibly, to talk a little bit more about model mechanics, but I just want to give you a quick feel. You see Will there in the picture working hard on his modeling part of the project. So I want to talk about why we would use landscape models to do this work. And landscape models are models that work at a kind of a broader spatial scale than something like FES or a fire model like FireSite or something like that. And the reason that we use models in general is so that we can get inferences or get information about places and times where we don't have any observed data. So, for climate change studies, it's perfect because we don't have the eye into the future. For something like modeling or trying to look at how management actions might affect things on the ground, it's a very risk-free way to do that, and also to look at a range of different actions that might be taken under these future climates, and try to get a sense for what things might work and what things might not. So typically when we do modeling exercises like this, we look at a couple different future climates because our trajectories of climate change are set by different emission scenarios that might be possible given what happens politically and socially in the world. And then also climate models envision the future somewhat differently. And then of course we have different ideas for how we might do management under these emerging conditions. And so for us, how we're, part of the way that we're viewing this modeling, in addition to getting some primary and really interesting information about these future conditions and future landscapes, we're viewing these models as a real way to create that manager-researcher interface. So a way for the people, Will and I, who are doing the modeling, and Lisa, to be able to interact with people who have more specific ideas about management actions that might happen, and to try to create something that that has as much of a degree of realism as possible. So this is really exciting for us to be able to do this work. Okay, so there's some caveats for how landscape models can be used, and then just how they work in general. What's really typical, or can be typical, when you show people results from a spatial model, one that represents the real places on the ground and real topography and real locations, is that somebody says, well, we call it my favorite pixel, like I have a cabin over in that corner, what's going to happen there? Or this is this particularly important spot for me, happens to be a really small space, again, my cabin, my protected place in the district or whatever, what's going to happen in exactly that place? And the benefit of a landscape model is you get to represent these broad scale processes like climate and fire and hydrology, but the downside is that they're not meant to do these really specific sort of point-based analyses. There's some ways in which the models were set up to select the treatment areas that we modeled that have to do with kind of basic stand characteristics rather than particular priorities about WUI areas or power lines or other types of concerns. And then we didn't model any other natural disturbances besides wildfire. So for this iteration, we have no bark beetles, we have no wind throw, things like that. Okay, so the two models are Landis2 and FireBGC. Will works with Landis2, and Lisa and I work with FireBGC, and they have a lot of similarities, and they have some differences as well. There aren't very many models out there that can represent interactions of climate, fire, and vegetation the way that these models do. So again, it's a pretty exciting opportunity to get to sort of look at these models in a comparative framework. And as far as Will and I know, this hasn't been done before. So we're learning a lot about landscapes just from being able to compare where these models converge and where they diverge, and we'll get to that later. But they both simulate, large spatial and long temporal time scales. They both represent spatial processes like fire and seed dispersal. They can do diseases. We didn't for this part of the project. They both stimulate interacting disturbance and vegetation responses to climate. So climate is a driver that affects both fire and vegetation in the model. They both deal with individual tree species rather than some kind of bigger cohort like conifers versus deciduous or something like that. We use them to look at specifically how treatments that we can incorporate in the model affect fire and vegetation properties. They both explicitly can incorporate weather and climate to control the processes of fire, and then also vegetation establishment and productivity. So a lot of similarities between them, and then some key differences in how they do the modeling. So our design for this project is 2 landscapes, the Kaibab Plateau in Arizona and the Jemez Mountains in New Mexico, and we have 1 model working in each of those areas. So in the Kaibab, Will's doing Landis modeling, and Lisa and I are looking at the Jemez Mountains using FireBGC. We have 3 climate scenarios or climate inputs that are common to these landscapes. We have a contemporary climate for each one that's instrumental weather from weather stations that are in each study area. We have what we're calling the warm, semi-dry climate future. You can see the climate model in particular and the emissions scenario. And if you're not familiar with the concentration pathways scenarios, the RCP 4.5 and 8.5, those are basically the newer version of what used to be something like A2 or B2 or A1B. And each of those emission scenarios describes sort of a story of the future in terms of how the globe is emitting or not emitting emissions, greenhouse gases. And so in 4.5, that's a more hopeful version of the future, where the emissions levels of greenhouse gases are lower. And so so related to that, the amount of warming and precipitation shift that's represented into the future is less extreme than in the 8.5. So that bigger number reflects a greater contribution by humans to global greenhouse gases. And then we have 3 management scenarios. They're a little bit different among the 2 models, both in terms of how we represent fire suppression, but then also in terms of how much area on the ground is treated, because we developed the management scenarios to be specific to each landscape to try to be as realistic as possible in terms of what people are doing on the ground. So we have a sort of baseline scenario, which in Landis means that fires are suppressed to kind of typical current levels, but no other management exists. So no fuel treatments, non-fire fuel treatments, no cutting, no thinning, no other things. And in FireBGC, we have this sort of hands-off baseline scenario where it's meant to represent as sort of natural a regime as possible. So no fire suppression, no management of any kind. And then for both of these models, we have business as usual, which Andy talked about a little bit, and that's a representation of the current extent and intensity of management in different categories of fuel treatments and fire suppression and fire use that are on the ground. And then the stretched business as usual for each landscape is basically 300% or 3 times the current treatment. So same general locations, same general types of treatments. We just allow the model to treat 3 times the area as currently specified. Okay, so just looking a little bit more specifically at the climate scenarios. So I talked about those different emission scenarios. So the hot and dry, so top panel is precipitation, middle is max temp, bottom is minimum temperature over a period from 1950 to 2100. The black line that you see represents the instrumental weather. So that's coming out of the weather station. And this happens to be a particular panel for the Jemez, but the Kaibab has somewhat similar climate representation. So black line is instrumental, and then the blue line is the more extreme of those scenarios, the 8.5. And so precipitation is lower, and max temp and min temp are both higher than the instrumental weather, and then this warm and semi-dry 4.5 emission scenario. So we basically have sort of a moderately sucky future and then a super sucky future. So we asked a couple of key questions, 6 key questions with this modeling work. The first is whether the particular emission scenario mattered. So is there a difference in 4.5 versus 8.5 in terms of what we see in the modeling results? Then we looked at changes in fire. So comparing management scenarios, so no management, current, and sort of amplified management, the stretch business as usual, and then comparing across the different climate scenarios. Do we see variability in area burn and crown fire? Do we see changes in forests? So among all those different scenarios, is there a difference in how composition, basal area, biomass, structure of the landscape is represented? And then we wanted to know where we're seeing big changes in fire and forest and when we're seeing them. So if I pop back to this climate graph, so these 3, let's see if I can use this fancy arrow. These 3 pink bars represent the 3 time periods that we're going to call out in this particular analysis. So 10 to 20 years into the future, 40 to 50 years into the future, and 90 to 100 years into the future. So does that period of time matter? So as we're moving forward in the future, are we seeing differences in the way that climate and fire are playing out and then affecting vegetation? So that's the when. And then overarching all of this is the question about management effects and effectiveness. So did we see a difference in the treatments that we modeled compared to one another and then compared to that baseline no management scenario? I think that's all I got. So if you had any quick questions, I could take them now. Otherwise, we could just carry on to the actual results.
So I think we'll dive into the results. Don had a question about the GCMs, but I'd like to hold that question until later on in the webinar because it's a little down in the weeds for kind of the focus of today, although obviously a relevant question. So let's turn it over to Will and talk about results from the Kaibab and get down to the nitty-gritty of the results, and then move in the later sessions into some of the discussion.
Okay, thanks, Xander and Rachel. And so, yeah, so I introduce myself. I'm Will Flatley, and I'm going to be presenting. I've been doing the modeling for the Kaibab landscape using Landis 2, and so I'll be talking a little bit about what we did and then showing you some results from the treatments and climate change. Okay, so the study area, my study area is the Kaibab Plateau, and so obviously some of you are very familiar with this landscape, although others of you will be less familiar. So I'll just give you kind of a general rundown. The area that I was modeling of the plateau is about 330,000 hectares, and it's a broad, high elevation plateau in northern Arizona, just north of the Grand Canyon. So the southern portion of the plateau forms the north rim of the canyon. Let's see, let me get the, oops. And so it ranges in elevation from about 4,000 feet to 9,000 feet. And this range in elevation provides a habitat for a range of different communities. So the kind of exterior here is the lowest elevation where you have pinyon juniper forest. And then as you go up in elevation, you have ponderosa pine, mixed conifer, and then spruce fir in the highest elevation interiors of the plateau. And so it's a good landscape to model, similar to the Jemez, where there's a range in elevation and a range in different forest types and corresponding fire regimes to look at how they might change under different climate scenarios and management scenarios. And then also just looking at the ownership, the green here on the left map is the North Kaibab Ranger District of the Kaibab National Forest. And then the southern portion of the plateau that abuts the actual canyon is Grand Canyon National Park. Okay, so moving on to the management scenarios that we tested, and Rachel gave, and Andy gave a little bit of a description of what these constitute. And so there essentially were 3 management scenarios that we tested. And they differed a little bit for the Kaibab versus the Jemez. And so for the Kaibab, that initial, the no treatment scenario has a base level of fire suppression. So when I calibrated the fire regime for Landis, I kind of based this suppression fire regime on fire records from the plateau, both the park and the Forest Service land for the last 40 years. And so the amount of fire was based on that kind of base level of suppression over the last 40 years. And so that's the initial scenario, is just that base level of suppression, but no, no fuel treatment, no prescribed burning or thinning. And then the second, the current or business as usual scenario was essentially trying to represent treatments that have occurred over the last 10 years in these 2 different landscapes. And so they still included that base level of suppression, but then I used the FACTS database and records from the Park Service, actual GIS polygons of where thinning treatments and prescribed burning treatments have been carried out in both of the different ownerships, and calculated this business as usual or current treatment rates within the different landscapes of both thinning and burning. And so these treatment rates are specific to the different forest types. So in the table down here below that's kind of showing you the numbers, that's for the whole landscape, the percent of that, the hectares treated, and then the percent of that ownership that was treated for the whole landscape. But these were specific to different forest types. So there was more area being treated in the ponderosa pine, let's say, compared to the pinyon juniper. So just keep that in mind as I'm going through these numbers. And so the current or business as usual treatments for the Kaibab or the North Kaibab Ranger District, they treated approximately 0.3% of the landscape with thinning treatments during this last 10-year period. And obviously, or not obviously, there is some mechanical treatment in the park, but we didn't model any mechanical thinning for the park landscape. And then if you look at prescribed burning, the Park Service, though, has treated quite a bit of their area with prescribed burning treatment. So that business as usual for the park area was treating 3.1% of the landscape each year, which comes out to roughly like 33-year rotation. So fairly frequently, and that is one difference between the Jemez and the Kaibab landscapes, that there is more area being treated in this business as usual and the amplify scenarios for the Kaibab.
Well, let me just interrupt with a quick clarification. Under RX burning, you're not including natural ignitions managed for resource benefit. Is that correct?
I am. So managed natural fire was included in my calculations of the percentage of the landscape that was being treated.
Okay, thank you.
Yeah. And then as I'm showing these, the kind of fire results going forward, and that's a great question, as I'm showing the results going forward, this would really be sort of unmanaged wildfires that we're looking at the results as we go forward that are outside of any kind of a managed fire regime.
Hey, Will, this is Nate Benson. Quick question on the suppression fires. Do you have a baseline percentage of acres burned under the suppression scenario? Just because some of those fires will escape containment.
Yeah, so you know, I don't have the numbers. I don't have the numbers in front of me right now. I want to say that it was about on the whole landscape, it was about 3,000 hectares per year is what I kind of calculated over that entire 40-year fire suppression period.
Okay, and then the other question is, are you going to include Park Service mechanical treatments? Because we do so when we're actually looking at funding an additional, I think, like 200 acres this year.
Yeah, so you know, at least for this original, these original runs, I decided not to. And you know, I talked a bit with Casey Teskey and Dave Robinson about this, and when I was collecting the numbers, and I know that they do treat, you know, do treatment along WUI, along roads, and around structures. But we just kind of decided to focus on larger scale treatments and not include that, at least for now, in the park. But you know, if we get into the discussion, we decide that we do want that's something that the parks, you know, just as a out of the box scenario, that's certainly something that we could add in, and we may want to add that to the out of the box scenarios.
Okay, yeah, I think it's a fair assumption you made. The only thing is, as we look at the out-of-box scenarios, that increased treatment along WUI and roads will allow that out-of-box scenario of more treatment by wildfire, more treatment by prescribed fire too. So it's a little bit of a balancing act, but it's
sure.
Like
okay, great. So yeah, thank you for the feedback. And yeah, we'll discuss it as we get to the end. Okay, so and then just, you know, basically the amplify treatments were 3 times the treatment rate. So for the Forest Service, you get up to about a 30-year rotation for the prescribed burning and thinning combined, and then for the Park Service, you're getting to 9.3% of the acreage treated, or about down to a 10-year return interval. Okay, so let's get into some of the results. And so just introducing these figures. So each of these, this is showing area burned in these different scenarios. And so each one of these panels here is a different climate scenario. And then within that, we have, you know, on the x-axis are different management approaches. So the suppression, the current or the business as usual, treating approximately 2% of the landscape, and then the amplify, or that 3 times treatment rate. And then within each one of those management scenarios, then we also wanted to, as Rachel mentioned, show different time periods. So you'll see results for the 10 to 20 years into the simulation is the red, and then the blue is 40 to 50 years into the simulation, and then the green is 90 to 100 years into the simulation. And so just kind of looking at the trends and the results, one is that, you know, there's a lot of fire early on in the simulation. So you can see those red bars tend to show the most area burned annually. And, you know, that may be partially due to, as part of this model, I'm modeling 120 years of fire suppression, and then we move immediately into the start of the simulations. And so that's a little bit different than what's actually occurring on the landscape, where there have been fires, some fires occurring, and some treatments that have already been carried out right prior to today. We're kind of starting in this model in a suppressed landscape. And so that fuel accumulation may be resulting in a fair amount of area burned early on in the simulation. But then you can see that one of the main results is that here in the 40 to 50 years and in the 90 to 100 years, you have a pretty clear management effect as more of those treatments start to treat more of the more of the landscape has been treated over time, and you do see a decline in the amount of area burned. However, not a whole lot of difference in terms of the different climate scenarios, even comparing the no climate change to our two future scenarios, not a whole lot of change in terms of the area burned. Looking at high severity area burned, really a similar pattern to area burned, and kind of similar trends with management reducing area burned at high severity, and particularly during that after about 40 years into the simulation, you start to see less area burned. And so I see a question about the total area, the study area. The study area is 340,000 hectares. So that's about, let's see, 10,000 hectares would be about 1% of the landscape. Okay, so going on to looking at forest characteristics and biomass. Landis, the way that it is set up, doesn't provide outputs of basal area. It's not tracking individual trees. It's a cohort structure. And so as a result of that, we've got to work with biomass. But in looking at these results, you can think of biomass as kind of corollary to basal area. And so in these graphs, we're looking at average biomass in grams per meter squared. And so, the main trend you can see in both the warm and semi-dry and the hot and dry, so these climate change scenarios, is that there's a pretty drastic decline in biomass over the course of the simulations. And it's, particularly drastic in this hot and dry scenario, so that kind of more extreme climate scenario. You really have a drastic decline in biomass across the plateau. And so, this is really the result of two processes that are occurring. So the first is just fire occurring in the landscape, and high severity fire, which is going to cause the overstory, right, cause mortality in the overstory, and then the combination of regeneration failure, or regeneration decline, and so regeneration, new cohorts not coming up and replacing that mortality, and as a result you have this fairly drastic decline in biomass over the course of the simulation. And not really a whole lot of difference in terms of management affecting the extent of that biomass decline. And so I wanted to kind of illustrate that. We're not going to look too much at really long term, but I wanted to just kind of show you with one slide the longer term curve of biomass decline. And so this is for that moderate scenario of warm and semi-dry. And so over the next 200 years, you can see that biomass really hits a minimum about midway through that second century, so it'd be about 2150, and doesn't really start to recover biomass until later in that century. And so just keep that in mind when I'm talking about the compositional change, and because remember that it's taken a long time for new species to start to establish and biomass to recover from the initial decline and mortality related to regeneration failure. Okay, so this is switching graphs looking at species composition in the ponderosa pine forest. And so each of these individual panels, like starting with this top left, is a different combination of the climate and management scenarios. And what you're looking at is the proportion of total biomass represented by each species. And so you can see in ponderosa pine forest, and here's the key down here at the bottom of the colors. Ponderosa pine is dominant in this ponderosa pine forest type in the sort of lower mid elevation. And similarly, right, not real interesting trends in terms of compositional change, but I want to remind you that to keep in mind that there is this biomass decline. So even here in the hot and dry scenario, not a whole lot of compositional change, but remember that that biomass has maybe been cut in half or even further, and so despite the fact there's not a lot of compositional change, it's still, ponderosa pine is dominating the percentage of biomass. These forests are declining and in response to the climate change. It's just that there hasn't been a recovery and uphill movement of lower elevation species. So if we look at, so this is the same graph, but just basically showing you instead of just 100 years, 200 years. If you look over here in, again, the hot and dry scenario, pinyon juniper and, pinyon pine and juniper are starting to replace the ponderosa pine. It just takes a long time for those species to get established and for the forest to start to adapt to the new climate changes. And really minimal impact of management, again, on what's happening in terms of compositional change. Okay, so moving up elevation to the mixed conifer and looking at species composition according to biomass. And this is back to, and I'll stick with just the 100-year time horizon. And so, overall, there is a shift in the two climate change scenarios from the mixed conifer forest type really towards ponderosa pine becoming dominant, replacing white fir and Douglas fir. And what's interesting is that one of the things that's interesting is that management does delay some of this compositional change. So by thinning and burning, you're preventing some high severity fire in these upper elevations, and that's reducing the rate of turnover and reducing or delaying this compositional change from mixed conifer to ponderosa pine domination. And then, interestingly, you'll notice the hot and dry, actually, that conversion is also delayed throughout all the different scenarios. And this is likely due to, in the hot and dry scenario, that the climate is really moving outside the range, the optimal range of ponderosa pine even. And so that's delaying regeneration of ponderosa pine and its increase in dominance in that mixed conifer forest type. And if you actually, again, look further out into the simulation into the 2nd century, this mixed conifer zone starts to be dominated by gamble oak and juniper. Okay, and then finally looking at the spruce fir results of species composition. Similar to the mixed conifer, you have an eventual shift towards ponderosa pine from spruce fir forest types and a decline of spruce, fir, and aspen. So those species, Engelmann spruce, subalpine fir, and aspen are not regenerating at all, even at the highest elevations on the plateau, under really both of these future climate scenarios. And so they're eventually going to be replaced, but it's just how long does it take for that overstory to be removed and for species to move uphill and replace them. And management down here, both the current and then the amplified management scenarios do delay that compositional change, and they delay the timing of the loss of spruce and fir species. So again, having more prescribed fire, more thinning, reduces the spread of fire into spruce fir, reduces high severity fire, and retains more of that those high elevation mesoconifers and aspen in the upper elevations. Okay, so just kind of summing that up. So, we're really asking about the effects of climate and what are their effects on fire and forests. And so, we found not a whole lot of influence of climate on particular fire characteristics, but the combination of continued high severity fire, particularly in the upper elevations, and then regeneration failure due to climate change drives this biomass decline and eventual compositional change in the Kaibab forests. And where are we seeing big changes? The most drastic changes in terms of particularly species composition are in the high elevation forests, but you do have that biomass decline in really all of from low elevations to high elevations. And then when are we seeing these changes? They really start to, you see the most drastic changes later in the century when warming and drying is more pronounced. And then, is management effective in trying to prevent some of these negative outcomes? And so the treatments do delay, particularly the compositional change in the upper elevations, although, those high elevation spruce, fir, and aspen are not going to regenerate under these future climate scenarios that we've modeled. So it's really a delaying of that change, and the change is eventually going to occur as some type of disturbance or just eventual mortality removes that overstory, and you have the new lower elevation species that are viable under new climate that come in and replace it. Okay, so I'll hand it off to Rachel at this point to present results from the Jemez.
Yeah, and let me just interrupt real quickly and make sure if we have any technical issues, we address them. So is everybody still able to see and hear okay? Maybe I'll phrase it another way. If you're having any problems, please speak up. Okay, then I think we can dive into results from the Jemez, and Rachel will be similarly brief, and then we'll get into the discussion.
Okay, Xander, thank you. I'll try to be brief. Modelers don't like to be brief. We like to be ultra detailed. Okay, Jemez Mountains study area, where we did fire BGC modeling, is probably someplace that many of you are familiar with. It's sort of north central New Mexico near Los Alamos and Santa Fe, as you can see. And it has some of the same vegetation communities as Will's landscape on the Kaibab. I think it's got a bit more lower elevation, kind of dry woodland area. This landscape is about 180,000 hectares, which translates to about 500,000 acres, so big from a modeling perspective. And about half of it overlaps with the Southwest Jemez CFLRP area. So that provided a lot of the inputs for us for the management treatments. Oh, and let me go back. So we have a diversity of ownership in the study area, including Park Service, so both Bandelier and the new Valles Caldera Park Service area. We also have tribal lands, in this case Jemez Pueblo, although the area is bounded by several other tribal ownerships, and then also a large component of Forest Service land. Okay, so for management scenarios, we base these on this EIS for the Southwest Jemez CFLRP. for two reasons. One, it was a good estimation of how these different treatments across the various ownership areas could be implemented, and also because these treatments were attached to goals, and so we could use those goals to sort of organize how we tracked the output. So in terms of evaluating effectiveness, these goals gave us a target. So you can read them there. I won't read all of them, but basically our business as usual scenario was use treatment guidelines from this alternative one that was in the CFLRP document. And the goals of that were to use these various methods of thinning and with full or partial removal and prescribed fire that are in the white background part of the table to restore structure, function, and resilience of ponderous pine and dry forests, and reduce potential for crown fires, promote the possibility of implementing or of allowing for low intensity frequent surface fires, improve habitat, and then protect a host of other important cultural resources. So in terms of the business as usual scenario, how those treatments were implemented, in this table I'm showing both the treatment area in hectares and the treatments as a percentage of the total simulation area. So what should jump out at you is that both numbers, however you look at them, are fairly low. So I don't think, we only have a few treatments in the amplified business as usual, or 3 times the level of current management, where we even see more than where we see more than 1% of the landscape even treated. So for most of these areas, these treatment areas, there's an extremely low or small footprint on the ground. So so that's sort of the take-home message of these treatments is, as these were defined, they're worthy targets, but from a landscape perspective, they still are a very, as I said, they have a very small footprint. Okay, so I'm going to jump right to results. These sort of follow the same format as Will's. So first we want to look at area burned, and so that's in all fire types for each of the 3 time periods where we looked. This is these are box and whiskers plots, and so the line in the middle of the box shows the median value, and then we have 25th, 75th percentile whiskers with outliers. And so the main thing that I see when I look at these is that regardless of where the time period or the climate change scenario, when we look, we see lots of variability, and that's pretty, that's fairly true to what we actually see in the world, is that we have years with mainly low value for area burned, and then we have these big fire years. And the small fire years dominate the data, which is sort of pulling that median line down. But we have the potential for these really big fire years in all of these scenarios. And so the y-axis for all of these panels is the area in hectares that's burned annually, and then we have the different management scenarios on the x, so no management, current, or business as usual, and the amplified or stretched business as usual, and then our 3 time periods in different colors, and then the 3 climate change scenarios, each represented as a different panel. What we also see is the annual area burned is about the same for unmanaged and amplified management once you get to the hot and dry, whoops, sorry, wrong arrow. Once you get to this hot and dry scenario here, we have about the same annual area burned in each of these, in the no management versus the amplified management. In other words, the effort to treat the landscape and extend 90% suppression rate is not having any effect on annual area burned. So if we jump to crown fire as a subset of that annual area burned, now we're looking at the proportion of those fires that I showed in the previous slide that are crown fires. And again, our management scenarios and climate change scenarios represented as panels, and on the x-axis, time periods by color. And so I think what will jump out at you, again, is this hot and dry climate scenario. So when we have more fuels, as we do with 90% suppression rate, that's our background suppression rate for all of these management scenarios. And I should have said that earlier when I was talking about the management, the scenario management levels, is that for the business as usual and stretch business as usual, both of those include this 90% suppression rate. That's was our reconstruction of the overall level of suppression that's been implemented in the Jemez. So when you have fire suppression at that level, of course we get this fuels accumulation that persists, throughout the time period of the simulation. When you combine that with these extra hot and dry conditions, as in this future climate scenario, it's a recipe for crown fire, basically. So again, the management strategies of thinning and prescribed fire that are implemented are not sufficient to limit crown fires because there's too much fuel and it's too hot and dry. So I wanted to take a brief look at fire return intervals since I talked about fire suppression. And 90% suppression, which is basically allowing 10% of wildfires to burn, obviously doesn't take all fire off the landscape. So if you look at what the fire return intervals look like under the no management scenario, so this column here, the fire return intervals are anywhere from about 1 to 20 to 100 years, depending on the elevation and the forest type. When we look at the current management scenario, we see that there is a decrease in the fire return interval. In other words, fires are becoming less frequent, and that's because we have that suppression activated in the model, and so fewer fires are allowed to burn. Under amplified management, we still have that fire suppression level, and so we still see fewer fires than under a natural fire regime. There are some areas where we see really frequent fires, even in those fire suppression scenarios. Those are because of the treatments, the prescribed burn treatments. So if we look at the difference that the climate scenario makes, I hope you can see that. Let's see if I can circle it. As you get to these hot and dry conditions, we do see more fire entering the landscape, sort of overwhelming the ability of that suppression level to constrain fire. So we still get less fire with these management scenarios than with no management, but there are other effects that we'll see. So turning to basal area, there are more crown fires in the hot and dry scenario. So that's reflected in this big change or big drop in basal area. So, so again, when you have more crown fires, you're obviously burning, you're killing more of the trees, you're burning off more of the canopy. Trees are still filling in, we still have recruitment, but these are very small stems, and so the basal area overall is lower. So, so that's sort of the take home there, is that this suppression level mainly is the effect that we see in the management scenarios of maintaining basal area, but then we get to these hot and dry conditions, and the ability of those treatments to constrain fire and therefore limit changes in forests basically disappears. So in terms of tree density, so this is an interesting graph. So I asked the question, why does tree density seem fairly stable regardless of climate and management? And it's the thing that I talked about before, where we're getting new recruitment in this model. We're getting establishment of small trees, but the activity of fire on the landscape, and especially that high severity fire, is such that those forests are burning and burning basically before the trees can get big enough to survive that level of or that type of fire. And so we don't have a density, we don't have a number of stems issue, we have basically a maturity of tree issue in looking at how forest structure is changing. So these are small stems or saplings with high mortality. So if we look at tree mortality, we see what I just pointed out, which again is if you get to these hot and dry conditions, which are not, they're not implausible at all. We do see that there's this high tree mortality in all the scenarios, and especially as we move to toward the end of the climate period, where the precipitation and temperature offsets are very much departed from what we see today. Okay, in terms of canopy cover, again, this result really just underscores that change in forest structure. So as we move through time, and we have increasing warming and drying in the climate scenarios, we see this big drop in canopy cover because, again, we're entraining those forests in this early successional stage. Okay, so let's turn to species composition. This is where some of the interesting stuff comes out in terms of individual species response to fire and climate. So this is the area that's dominated by ponderosa pine forests in the model. And so this is middle elevation, dry forest. And so the colors are each individual species. So let's see, this green here is ponderosa pine. And we have pinon here, and we're not modeling anything like Ips, and so pinon does quite well. And then here we have juniperous species in the model in that kind of dark red color. So basically, the overwhelming result is that as we get warmer and drier conditions, ponderosa pine dominance decreases, and so pinon and juniper fill in. And when I first saw the result, I thought, oh, is that really likely to happen? But then I started reading papers and talking to people and thinking about what I'd seen on the landscape, and that actually is a fairly that's an observed phenomenon. Probably many of you have seen it, and it's something that Will's modeling shows to be an outcome as well. And so you get this sort of shrinking of the ponderosa pine area of dominance and infill by pinon and juniper kind of at the margins. So again, that change in pinon, that increase in pinon is predicated on the fact that we're not showing anything like Ips or drought stress that contributes to Ips outbreaks in the model. And so what you could consider is whether juniper would fill an even bigger part of that ecological niche. So the other thing that you can think of this as representing is a transition from forest to woodlands with the hottest and driest of the climate scenarios by the late 21st century.
Rachel, a question came in about oak. Is this a good time to comment about how oak is included or not included in things like the estimates of stem densities?
Yep. So oak is included, and so that little, yeah, Ellis, I see that's your question. Good question. So let's see if I can use these pointers right. So this color right here, this little, I don't know, this like peppermint, I don't know, greenish color in the corner there is oak. And so we do see it coming in to that, to this system later in the simulation. I can show results at the end of the webinar or offline for the lower elevation areas, which are the pinon juniper dominated part of the landscape, and there we see oak become extremely dominant early on. And so I think these graphs represent species composition by biomass, and so what's happening in this representation is oak is there. It's in the understory. It becomes more dominant as the canopy opens, but the comparison of oak biomass with these other trees just means that it sort of exists. It's not showing up as dominant in very much of the landscape, but it's absolutely there. And Ellis, if that's something that you're interested in looking at, we could pull oak out because we're modeling it as an individual tree species and just look at its dynamics alone. But in the representation of oak and pinon juniper is extremely interested. I mean, it comes in super dominant. Okay, So turning to structural stage of that same area of the landscape, that same forest type, basically what we see is with increased fire, especially in the hot and dry scenarios, we get younger forests. And so everything about the sort of the forest type output underscored that we're seeing this transition to, we already have sort of, because of logging and because of, fire exclusion and resulting high severity fire, we already have these dog hair stands. They're quite young compared to, our vision of this, mature tree, more open ponderosa pine forest. These fires that occur, and especially crown fires with fire exclusion and with hot and dry conditions, basically, again, entrain the landscape in, an endless cycle of small diameter, relatively young dog hair. And so that's what we're seeing in this output. If we look at where the larger trees and when the larger trees stay on the landscape, we see them in these, with the no change climate, where, let's see, so this blue color, which are large trees, are maintained at a greater proportion of the landscape. When we have a no change climate, also when we have basically, interestingly enough, this current management, at early on or with no climate change, seems to do an okay job of maintaining those large trees for longer. But then, we get these big spikes in the sapling stages. So with fire suppression and the resulting fuels accumulation and high severity fire, poles and saplings, really begin to dominate the structure of this landscape. If we look a little bit higher elevation, at mesic mixed conifer forests in terms of species composition, we maintain kind of a current compositional mix of these species. So here, let's see, the dominant species here on the landscape represented in colors up here with their 4 codes. So oak in this green color, Douglas fir in orange, ponderosa pine in green. We have these other species in sort of lesser amounts. We have juniper, we have pinon, you can read them there. So basically we maintain this compositional mix at relatively stable proportions of the landscape regardless of management scenario or climate. We do see a spike in oak with the hottest and driest climate scenarios in these upper elevation forests as well. So again, we have more fire there as everywhere else, and oak responds very well. But in general, these mesic mixed conifer forests appear to be less sensitive to climate changes and changes in fire regimes than the dry forests down below. If we look at structural stage, we see sort of a similarly stable view, not much difference among scenarios. We see have an increase in the large tree representation on the landscape, which means that mature trees are surviving the fire events that occur and growing into this large tree category. And we do see some mortality in mature trees and infill by saplings, but again, that's sort of typical, mixed severity successional pattern. So, so this suggests that there's not, that the real focus of, sort of restoration and land management might be better placed in those lower elevation dry forests. So again, just to review what we asked and then what we found, we wanted to see whether that, the particular climate scenario made a difference, and I hope you're convinced that it did, that RCP 8.5, the hot and dry scenario, really changed the outlook for forests and fires in the future with reduced basal area and canopy cover, and changes in forest structure favoring those early successional stages, those dog hair, high density, small stems, and also pinyon juniper over ponderosa pine. Those changes occurred particularly in dry forests, particularly later in the century when warming drying is more pronounced and diverges more from the current period. And then, in terms of asking the question of management effectiveness, did the treatments that we modeled, those small amounts of thinning and prescribed fire work? Well, the greatest effect by far in terms of management effects on fire and forests happened because of that 90% suppression level, which again, we saw work if by working we mean restricting area burn and crown fire. They had some effect for a while, but as the climate picture gets less and less favorable for maintaining those suppression levels, it's hotter and drier and fuels accumulate more, there's basically a failure of maintaining that suppression level, and the resulting changes in forest structure, composition, and forest attributes is quite severe. So with climate changes, with management, we saw as much area burn and crown fire as with no management, but we also see increased tree mortality, younger forests, fewer big trees, more pinyon juniper coming into the ponderosa pine. And so I think, Will, are you going to take on this one?
Sure.
Okay.
Okay, so yeah, just kind of summing up a little bit of comparison on how the models were similar and then how they diverged in terms of their results. Starting with some of the similarities is that, so clearly for both models, the climate changes and adding into that kind of the effects of fire suppression and fuel accumulation caused shifts in fires and forests. And so changes in the forest, we both found compositional and structural changes, which included basal area or biomass declines driven by fire. And we also found, both of us, regeneration decline of species in their current elevation. So, as you would imagine, as climate changes, that the species in current locations become less viable in those particular locations. And so, it's not only the fire that's causing reductions in basal area or biomass and these structural changes and compositional changes, but it's also that reduction or kind of failure of regeneration of the current overstory species. And then uphill movement of species. So, it takes a little bit longer in Landis than it does in FireBGC, but, we both found that shift in the dry forest or the ponderosa pine forest from ponderosa pine to pinyon and juniper. So those are some of the similarities, and then differences between the two models. One of the important differences is that so management did have some detectable effects in the Landis modeling, whereas the main effect, it looks like in FireBGC, is due to fire suppression, not those fuel treatments. And so, this could be, one obvious potential driver of this would just be the difference in terms of the percent of area treated in these two landscapes. So, I think for Rachel's, even the 3 times treatment level or the stretched business as usual is only getting up to maybe with it 2% of the landscape, whereas in my scenario, that's kind of where you're starting with the business as usual, and then the stretched business as usual is treating 6% of the landscape. So just that difference in terms of the amount of area treated might be one of the things that is a cause for this difference in terms of whether management is having an effect or not. And then one other difference is just the landscape, portions of the landscape that we found were particularly vulnerable. So with my Landis simulations and on the Kaibab Plateau, I found, that there's biomass decline throughout all the different forest types, but the compositional change is most drastic in the higher elevation forests, whereas for FireBGC, Rachel found that, it was really the lower elevation forests that seemed to be the most vulnerable to change. Okay, and then let's see.
Well, I forgot. The next slide is just a little note that I had.
Okay, yeah, I'll let you talk about that, Rachel.
Okay, so I don't know if any of you all noticed in the FireBGC outputs, but in for some of the categories, there seemed to be this odd effect where you would expect that the current management treatment would have less of an effect, a positive effect, let's say, than the amplified treatments. But what we actually saw was that the current treatments, the business as usual, which treats less land area across the simulation area, we were seeing sort of lower values for annual area burned, or lower values, more positive values for basal area, maintaining some of the desirable attributes on the landscape more than this amplified scenario, right? So that seems sort of counterintuitive. It seems we would expect that as we had, sort of more of a restorative or a, treatment plan on the landscape, we would see more favorable results. And so we wanted to see why that was. It seems really odd. Well, so we put together this output. So first of all, I wanted to show where these treatments are occurring. And so the way these graphs work is that the colors represent the number of treatments over the simulation period. And so this is across the replicates, across the individual model runs that all make up a single scenario. So blue means the landscape was treated once. Red means the landscape was treated, 75 to 100 times. So 75% of the simulation time there was a treatment going on. So one thing that should pop out at you is that there are vast portions of the landscape where treatments don't happen. Another thing that is interesting is that there really doesn't, except for small patches where your eye can pull out, a little bit more blue, or an area where we have, oh, and I see a question from Amy. Amy, do you not see anything on the screen right now, or does anybody see a figure on the screen right now?
I do. Let me take control.
I got kicked out of the whole thing, so I don't know.
Yeah, I have a slide on the screen.
Okay, good. I don't want to keep talking about something that you all can't see. So there's some areas where there's slightly more frequent treatment than others, but for the main part, the treatment maps for these two scenarios are the same, and there's a couple different reasons for that. One is because regardless of whether if the treatment area is 0.5% of the landscape, even if you triple that, it's still a relatively small proportion of the landscape. So we're seeing these incremental increases in area that are, they're not detectable unless you really stick your eye close to the screen. But that's not the whole story. So that's small annual treatment areas definitely result in, big patches of untreated area. Another reason is that FireBGC has these rule sets that we enter that we took from the treatment plans in that Southwest Jemez CFLRP document that basically describe the characteristics of a stand that can be treated. And so I listed those thinning treatment details and prescribed burn details below. But so in a 100-year simulation period, as exists in real life, and I'm sure you all have experienced this before, you can treat a stand following certain criteria, and then in 5 years or 10 years or 15 years, that stand basically has returned to its previous characteristics and is available to be retreated, right, or could be retreated to fit your prescription guidelines. And so that's what's happening in the model too, is that some stands were treated early on, and they're ready for treatment again and again and again. So that vertical sort of column that's always orange or red is an area of the Pueblo, and that's where there's a prescribed fire treatment. And so, yes, thank you. And so that area is available, at a relatively high frequency for retreatment based on the criteria we put in. And then the third thing that happens that is the reason that the current treatments sometimes seem to have more effect than the amplified treatments is very, very interesting in this model. And that's because we actually run out of stands that are available for treatment in the hot, especially in the warmer, drier climates. And that's basically because we're telling the model that based on our our input guiding document, this minimum stand and maximum stand basal area to thin, and then the minimum diameter and the maximum diameter to thin. And so again, that's taken from these documents, but remember that I told you that with hot and dry conditions and the fuels accumulation because of fire exclusion that then results in crown fire, we're entraining the landscape in those dog hair thickets, those small diameter dense stands. Well, so we might have the basal area to implement a treatment, but our minimum DBH might be below that threshold. And so what the model is doing is, it's going through and it's looking for stands that fit these criteria, and it's saying, well, I can't find any, and so it doesn't meet its treatment quota. So even though we're saying, well, instead of 0.5% of the landscape to treat, you can now treat 1.5% of the landscape. It actually can't even find that small amount to treat. And similarly with prescribed fire, if it can't, if the model can't implement a fire that stays below the desired burn intensity, then it won't implement that treatment. And so if the fuels accumulation is such that that's not possible, or the weather year is such that that's not possible because fuel moistures are too low, it can't implement that treatment. And so, yeah, so it's sort of this funny effect where, there comes a point where even though we're saying, you can do more, we actually can't do more unless we change our treatment criteria. So I just want to leave that as food for thought as we think about out-of-the-box treatments, is that I would say something like more, better, sooner would be some good guidelines, at least from the modeling perspective.
Great. Thank you, Rachel, and thanks for kind of honing in on some of these particularities of the model. So we really want to turn the tables now and hear from participants on the line. And we've got sort of these three categories. One is we want to think a little bit about the management scenarios we used in these models. And I think we'll hone in first on the Kaibab because we have some expertise on the line from that area. And so we want to think about how we frame the business as usual. Did we do, are there things that we could do to make that better reflect reality? And then we really want to talk about, well, if some of these constraints were taken off, and Andy talked a little bit about this at the very start, what is the sort of out-of-the-box, sky's the limit, kind of what could we do to try to change some of these trajectories? And thinking about some of the management targets. When do we know that management has been effective? We've been, in a lot of conversations, we sort of talk about area burn at high severity or something is one. But there may be other fire regime or vegetation indicators that we haven't thought of that you guys use in your landscapes or in your day-to-day. And I think the next round of model results, that'll come later, so we don't have to worry about that. So really, the first question that I'm about to call people out and ask is, what's your reaction to these model results? And I think maybe thinking about both the scenarios as well as the results. Any volunteers to give some thoughts about some of these results, maybe starting with what we're looking at here in the Kaibab? All right, so someone's got to speak up. Randall or Gary, you guys from or Paul from the Kaibab office over there, what do you guys think when you see this?
Yeah, this is Randall. From what I see, it's what I've seen in other models and things. I guess I'm wondering if there's a veg type missing at the lower elevation, maybe woodland, oak, and grass that I haven't seen, because we do have, we had the Bridger Knoll fire where it looks like we probably changed from the pinyon juniper to a different type of model, which is lower. Other than that, I'm.
Sorry, go ahead.
It seems like we haven't really incorporated, you know, this is fire only. We're not putting the insects and disease in there, which I was in silviculture for 35 years, so you know, I always try to put all those things in there. But I know when you're modeling, it really skews the results sometimes, and makes it much more difficult to interpret what you're getting. You know, because I see in the pinyon juniper, there's some sort of needle cast or something going on out there on the plateau, and I'm not sure what that is. Personally, I haven't seen anyone really address that. I also know that at the higher elevations, it looks like we had it was actually FireCLIME was probably more ponderosa pine before we kind of changed the scenario with fire suppression, you know, 100 and something years ago. I see a lot of big pine and a lot of ingrowth of mixed conifer and spruce fir there as well. So I don't know how you're taking, you know, those sorts of changes into account when you're doing your modeling.
Yeah. Okay. Well, yeah, I'll sort of comment on. So you're talking about the lower elevation vegetation type that maybe is missing, and I agree. So Landis is just modeling woody species, and so we can, you know, we really decided just to go down to kind of the pinyon juniper, but we can track non-forested area, and I've done that for, you know, I can actually do that with these results, and I've done it for a previous project where, you know, we can look at the conversion to non-forest, and you do see that in sort of as the climate change progresses, that that particularly the pinyon juniper starts to convert to non-forest, which, you know, we'd interpret as being like a grassland condition. And then, you know, about the multiple disturbances, I agree, and I think it's something that you really do have to keep in mind, particularly, you know, the reason, and you touched on this, is just that one is that you just can't model everything, or it becomes harder to interpret what's really driving change, what processes, as you start to include more processes, you know, more disturbance processes. And so I don't think we will for this project, but in these models you can model insect and disease outbreaks, so that could be something to combine and look at interactions in the future. And then, you know, related to that, when I look at these results and start to interpret them, for the Landis, I think that you have to keep that in mind, and as a result, interpret them that probably changes may occur earlier, and turnover may occur earlier in simulations than we're finding, right? So, you know, the compositional change and the biomass declines is really occurring later in the century, but if you combine both fire and insects and disease, that decline is likely to occur earlier, and either result in compositional change, or perhaps, you know, non-forested area, as it takes time for species from lower elevations to seed in. And then, so, you know, talking about the upper elevations and those like mesoconifer spruces and firs, that you know, certainly I think in the dry mixed conifer and parts of the wet mixed conifer, you know, my understanding is that that was dominated by ponderosa pine, and even maybe into the spruce fir historically. And so, you know, some of this change may be more of a shift back towards those conditions, but, you know, those spruces and firs are potentially not going to be viable anywhere in the landscape. So, you know, they must have been somewhere, perhaps in wetter, you know, in draws, or on really north-facing wetter slopes. and those, the really change from a historical condition is that those species may not be anywhere on the landscape. But yeah, I mean, that's those, all good points and things that we kind of think about, and certainly we'll keep in mind when presenting these results in future webinars and in publications, is kind of talk about those caveats.
Great, thanks, Will. I want to push a little bit deeper on just the scenarios we set up. And Randall, you were nice enough to speak up before. I'll maybe start with you again. When you look at this current sort of business as usual, what's happening today, and these numbers of acres of thin and managed fire or prescribed burning, and the amplified case, what are your thoughts? I mean, Nate talked a little bit about maybe some acres missing in terms of the business as usual for the Park Service side on thinning. Are there other comments like that about how we're thinking about this setup, this scenario?
Yeah, I'm not sure. It sounds like you were using facts as your database to pull the numbers for what we're actually doing as treatment, and I think that reflects what we've done on the ground. As far as thinning with, say, timber sale projects, those I don't think show up until we actually do it on the ground. We have actually sold probably more acres of treatment than are showing up there, and it's all based on budget and how we get funding. I think the CFLRPs and the CFLRs that are out there are really good projects. I sometimes wonder if they skew the budget, to one side, and then other places don't get as much attention sometimes, because we can only do as much as we get money for, and that's what we're doing. We do get extra money at the end of the year when other folks that get it turn it back, but we're trying to do as much as we can. If we got more money, we would certainly do more, but the scenarios, I think, are looking good. So I don't want to beat a dead horse, but imagining a scenario where Congress, society said, this is really important, we need to allocate more dollars to Forest Service budgets and treatments, and it was a situation where you felt like, boy, if we ask for money, we're going to get it. Do you feel like that amplified sort of treating 3 times what we're kind of currently doing? Is that a, with essentially this dream scenario of unlimited budgets, is that the right place to kind of shoot for? Or do you feel like with the right money, and that means you could hire some more people and just really get things moving, could you even, would 5 times, or would it be skewed differently in terms of, we just did a simple multiplication just to try to have something to look at, but would it make more sense to say, well, look, yeah, we do a little bit more thinning, but we'd really expand our expire, or maybe vice versa. Any thoughts on that? Yeah, I think it would be good to show a scenario. I mean, the time it's going to take us to actually get across the plateau with treatment with these percentages is pretty, it's pretty long. And we try to strategically place when we do projects, and that probably doesn't really play into the landscape model either, as far as the amount of acreage that would be burned. But a 5 times model, I think, would certainly be a valid thing to shoot for.
Yeah, this is Nate. I got a question on that, because under the scenario, I guess in the spruce fir, you can delay compositional change, but eventually you're going to end up with a change. And it seems like another the hot and dry scenario, as you get further out, we can have some impact. It may delay the change, but eventually the change in species composition is going to happen according to the model. So you could say, well, that'll give species time to adapt. 200 years is as much time to adapt. So why would we push that? You know, why would we push trying in some of the areas, trying to manage more aggressively when we're not really giving that much benefit in the long term?
That's a great, and I think worth some discussion. And let me see if I can reiterate it so that I'm sure I understood it. It's really a question of some forest types are, well, to put it bluntly, sort of on their way out given these predicted climate changes. And so we could manage the heck out of them, but they're still on their way out. And so another approach would be to say, well, let's not monkey with them and keep them around as long as we can. Is that a fair paraphrasing?
Yeah, yes. It's why are we trying to maintain something that's on its way out, and unless there's another shift in the veg type that we want to help support. But yes, you paraphrased it correctly.
Anybody want to weigh in on that?
Here, I'd like to comment. This is Paul Calloway, North Carolina.
Great.
I contend that, you know, a lot of our stands, 8,500 feet and above, we're losing a lot of our pine and aspen to the encroachment of spruce and fir. If we could thin the stands heavy enough, we can set back the composition to the early cereal pine and aspen type that is more fire resistant. And so, you know, and it's pretty obvious the biomasses levels are way high. If you look at the Langen-Stewart survey of 1909, I mean, they talked about open stands that a wagon could go through. I mean, I contend that we are way overstocked from the variation of historical variability conditions. We do have a new forest plan that's a lot more aggressive to try to bring us back more to those conditions, but I contend a lot of our stands are way out of whack. As far as the species composition and the model that you showed, the screen that has the pine, you showed the spruce and fir increasing, and I don't agree with that on that screen that had pine composition. There's some of the things of this model I'm kind of scratching my head, but I'd need to think about it more. I mean, we're seeing a ton of aspen come in where we're logging and or prescribed burning. We do not have the elk herbivory pressure that the south side does in other places. We're seeing tons of aspen. But if you look at this hot and dry last panel here, you're showing oh, Pied, let's see. Oh, okay, that's, I thought that was spruce. I'm sorry, I apologize. It's pinyon pine increase. You know, I think we can control our composition through thinning and fire over time, even if we do get hotter and drier. If we could focus on those early cereal conditions or mid-cereal, you know. But anyway.
Yeah. So, I mean, the idea would be to go in and thin and target the you know, fire-resistant, sort of drought-resistant pines, ponderosa pine, Douglas fir, that historically dominated in these stands, and to sort of get ahead of the direction that climate is going. And so, yeah, I mean, I think that partially some of, you know, the thinning that is being carried out in the mixed conifer in these stands is doing that already in the business as usual and amplified scenarios. But yeah, I mean, that would be one potential strategy, is to do more of that in those higher elevation forest types, to thin towards ponderosa pine, Douglas fir, and start to create that shift rather than having high severity fire do that change for you and potentially having it become non-forested or sort of a reduced, you know, early cereal stage or reduced biomass forest.
And I think it's important to recognize different land management agencies have different responsibilities and tasks. So I know in FireBGC it's broken out by the rules are determined by land management, land tenure. Is that the same in Landis, Will? So are the rules for what happens on the park side adjustable versus what happens on the Forest Service side?
They are, yeah. And so, you know, we could design different treatments for the park versus the Forest Service, and that's already somewhat represented in terms of the there not being you know, mechanical thinning in the park. But yeah, we could create you know, we could create a different thinning treatment for the Forest Service that would, let's say, you know, remove everything except for ponderosa pine. You know, we could target different species, and we could also target, we could change the amount of the intensity of thinning, so how much biomass you remove.
So I actually hear, and let me, tell me if I'm getting this wrong, but both Nate and Paul are basically kind of saying the same thing in that why would we put our efforts into trying to conserve something like spruce fir on our landscape when that's already, you know, many of the species, and you see that white fir coming down into the ponderosa pine, and, you know, we've had this change already, and so why would we not work to put the treatments where we can shift those changes to be up on the landscape higher and potentially work better with climate? Am I getting that right? And why would we put effort into something like spruce fir, which might just be gone anyway?
Paul, here, at least on the North Kaibab side, we do have pine and aspen even up in those highest reaches in our spruce and fir. It's kind of an anomaly, even though the stands type out as spruce and fir. But it's real disheartening to me to see these big old pine that are just real scattered with no regeneration of pine, just being choked out by spruce and fir and the aspen. I've convinced myself that there was always pine even at the highest reaches of North Kaibab. But,
so that might be an opportunity to actually focus your treatments in those areas, but not to promote spruce fir, to promote lower elevation species being able to move up.
And more fire-resistant, pine and aspen, much more fire-resistant than the ladder fuels of the spruce and fir.
Yeah.
Yeah, you captured my thoughts, Andy. That's pretty much it.
Yeah, and pine is going to continue with climate change to be viable in those highest elevations, so you're moving towards something that may be more stable in the long run.
And the thicker bark, you know, more fire-resistant as well. Paul here, I just wanted to mention that, you know, Kaibab Industries shut down in '95 here. They were treating 10,000 acres a year. They broke the North Kaibab, the commercial base, into 20 of these planting areas. Now, they weren't treating every acre, but they were covering these about 10,000 acre landscapes, one per year. I was doing the math. That's about 4,050 hectares. That's where I'd like to see us at. I'm not saying logging that many acres, but treating with, you know, mechanical and or fire. That's just my 2 cents worth.
I'm sorry, can you repeat those numbers again? Because that's an interesting, I think that's a neat reference point.
Well, logging-wise, they were cutting 40 to 60 million board foot, so you can double those numbers for CCF. But they were covering 10,000 acres a year up on that's on the Forest Service side of the plateau in their heyday. Right, Gary? I believe that's what they were doing. And so I think we need to take about 6x instead of 3x would be my hopes and dreams for the future. I think in the next couple decades that 3x is the most we can hope to do. I mean, industry's got to be there. Who's going to do the work if you're going to do mechanical, unless we get a lot of grant money and Elk Foundation money and all. But we've only got 2 sawmills here, and they are maxed out. They cannot do more, and they're slow. But we lost this powerful tool, Kaibab Industries, back in the day, whether you like logging or not. They were doing a lot of really good fuels treatments of them, mechanical.
Thanks. That's helpful. And I think it sounds like there's that might be a good benchmark in terms of, area or goals, but it also seems like maybe the material, the sort of rules for what's removed might be significantly different in terms of going for smaller diameter stuff or this issue about retaining the more fire-resistant Pondo or something like that.
Yeah, I noticed the Jemez example. You had a 16-inch diameter cap as I convert the the metrics there. But you know, we've got a lot of large trees here on the North Kaibab, as y'all probably know, and so. But the new forest plan has us thinning through all the size classes and fairly aggressively. So we'll see how that goes. But we're all in it together. So.
Great. Well, are there other comments about either the scenarios or maybe we can change the conversation a little bit to whether the some of the impacts that are modeled out based on those scenarios line up with, you know, sort of common sense might be a stretch, but your expectations, or are there things that you saw in the modeling results that really leap out to you either as surprising, but when you think about it, makes sense, or really sort of counterintuitive and maybe something that we need to go back and understand a little bit more about, like Rachel did with the area treated. I'm very curious, you know, and things like when we look at this fire area burned, we're seeing that they're under even some of these hot and dry or warm and semi-dry in the later periods under current or amplified, we can see that dropping off. So any reactions to this slide or some of the other result slides?
This is Nate. I have some comments on the Jemez, and I don't know if you want those now or later.
Oh, yeah, let's jump to the Jemez. Let me think about which slide to. Similar slide in the Jemez, probably.
Hey, while you're doing that, Xander, Ellis, so you were asking about, are the models locating treatment strategically to maximize the reduction of fire intensity? You're thinking of Ager's work. And so they are, at least in Landis, it's prioritizing where the treatments occur according to the fuels or the fire hazard, basically a fire hazard characteristic of a particular stand. So just in terms of, you know, what the fuel type is, and if there's a high fire hazard, that is going to be higher priority in terms of treatment. Although it's not going to, if you're getting at, you know, spatially locating them across the landscape, like dispersing them in certain patterns in order to reduce fire spread or fire severity. That's not occurring. That, you know, that type of planning that would, you know, really require you know, assessing that at each step of the modeling.
Thanks. Nate, was the slide that I have up currently, is that a good place to build your comments for the Jemez off?
Yeah, I'll give it a try. So one thing on the NPS lands when we're looking at treatments in areas that have been treated, and I wasn't sure, Rachel might be able to help me on this, on the modeling side is, you know, with Cerro Grande Los Conchas fire and then looking at the Thompson Ridge fire, a vast amount of this landscape has burned in the last 15 years. And so many of these areas aren't going to be treated for a while, and in some of these areas are type converting, where it's moved from pinyon juniper to shrubland, et cetera. But the one area is, if I look at Valles Caldera, and they are part of this resilient landscape program with part of the Forest Service CFRL prior to that, and they're chugging away, treating a little over 1,000 acres a year. They'll even be doing more with prescribed fire. And the way they're treating that landscape is the Thompson Ridge, I may have my numbers wrong, but the Thompson Ridge burned a vast percentage of their lands there. So now they're treating the last 50,000 to 80,000 acres, I think it is. In the next 10 years, they're trying to allow that to thin it out, use mechanical treatments, prescribe fire to create resilience. And that's by one question or looking at the treatments and the changes, is so much of the landscape has already burned, it's hard to even look at it in treatments until we look 20 years from now or 15 years from now. So it's not a very precise question, but that's the concern I was having with the model.
Well, so I think the easy answer to your question is to let you know that, so when we built this model, we used, current stand conditions. And the way that FireBGC is parameterized is I went out and I did a couple of years worth of field data to get representative fuels and stand, stand information for different areas around the Jemez. And so, those were various plots in various forest types at different successional stages, and in different areas, and everything in the Jemez has been treated one way or another. Logging, grazing, fire, decades worth of treatment, and so, but all of that happened before Thompson Ridge, or some of it was during Thompson Ridge, and then we didn't include the sort of the most extreme expression of burned areas in Los Conchas. So this landscape is effectively not representing that few years post-fire stage. It's representing, it's probably more representative of 10 years after a big fire event like Las Conchas. So that's one way of answering your question, is we don't, and the model wouldn't be putting treatments in those recently burned areas anyway, just because there aren't the conditions that meet those treatment criteria. But basically what happens in the model is, you've got this landscape that's represented, detailed fuel, tree, understory, overstory information that's overlaid on, a topographically true representation of the landscape, and fires burn immediately and they alter the vegetation. And so from that point, from year one, you're getting sort of a holistic landscape scale picture of how disturbance in climate and vegetation species interact. And that's sort of the my favorite pixel thing. It becomes at that point detached from the precise history of individual activities that might have been the precursor to those landscape dynamics. But that's okay, because we're asking different questions. We're asking questions about this complex spatial, interaction of processes and the results for these, vegetation and fire characteristics. I don't know if that's answering your question.
I think you are. I think you're getting there, because in summary, you've taken those changes into consideration, but you're really looking, let's say, the option 20 years out, you're really looking at the landscape 20 years later. So those changes that have occurred relatively recently are already factored in to the model, and that's also what gets at the whole issue of the treatments, because so much of the landscape is in sort of sterile stage to begin with.
Yeah, and if you look at the area burned outliers, some of those are Las Conchas events or Thompson Ridge events, well, more like Las Conchas, so where more than half, 2/3 of the study area is burning in a year. And so everything that follows from one of those outliers, from one of those big fire years, you could think of as being a trajectory of recovery or failure of recovery, or a new trajectory of recovery under the management and climate conditions that we impose. So it's like looking at a bunch of different futures from the starting point of today, where we're not modeling individual specific events that might happen. We're not saying Las Conchas is going to happen in this place at this time, at this regularity. The model is the elements of the model that dictate how fire happens on the landscape, which are extremely responsive to both the bottom-up fuels and the top-down climate, are creating those dynamics.
Yeah, that makes sense to me.
Okay, thank you.
So we're coming up on 2 hours, and I want to let people go about the rest of their day. But I see Priya's question in the chat window that I'll bring up. And then, Andy, I'm warning you that if there are things you want to connect in to wrap up, you should be framing those in your head. But so Priya asked about fire suppression. And I think it might be essentially she's talking about what are the model assumptions about suppression and how do those map out into the future. And so maybe Will and Rachel, if you can just very briefly kind of comment on what suppression what the suppression assumptions are and how those change over time, with cognizant of the idea that thinking about what the suppression budget or suppression effort might be over the 100 years of the model. That's a not insignificant question. So Will, maybe you want to start?
Sure. Yeah, so suppression in land, and it's different for the two models. So in Landis, it's a consistent sort of fire regime that's based on the last 40 years and kind of the level of suppression that was occurring, and obviously that changed over that time period, but it's sort of like an average level of suppression over that entire period. And so essentially what you're doing is that going into the future, you're assuming that, and this is, you could certainly question this assumption, but that you're going to have basically an equivalent number of fires that are going to escape suppression and burn as sort of uncontrolled wildfires. And so that's, not changing, in my scenario, is not changing into the future. You're going to have a similar number of fires occurring, although the size and severity of those fires is going to be altered by the changing fire weather over time. And so, you could, like if you wanted to model a change in, the money put towards suppression or the effectiveness of that, you could reduce the number of ignitions or fires that are basically occurring on the landscape that would, basically imitate a reduction in the number of fires that are getting away and kind of an increase in the effectiveness of suppression. So then it's different for FireBGC, so I'll pass it to Rachel.
Okay, thanks. Well, yeah, I think I'm the one who said suppression failure. So, so when I use that term, what I meant was that so basically the way suppression works in FireBGC is there's a number of starts that are modeled at the sort of natural fire regime level, and so we'll call those 100%. So that's 100% of fires burn. With suppression set at 90%, 90% of those starts are basically put out before they do anything in the model. And so we have these 10% of fires that are left, and those 10% of fires basically those 10% of fires are accounting for a lot of the area burned in the model. So they will burn in a potential area until there's a topographic barrier or until there's a fuels loading or fuel moisture barrier. The logic is the same as the FINI model, so I'm sure you've used those, many of you, and so you kind of know how, FARSITE or FLAMAP or, at its core behave, the Rothermel fire spread equation. I mean, all those models basically use the same logic as does FireBGC. And so what's happening is that there aren't the conditions either with, a previous history of fire that's creating this, mosaic of burnable and non-burnable areas. There's not that history on the landscape, and then there's also this fuels accumulation year after year after year of suppressing these fires. And so, in terms of what a budget would be to create an effective and persistent 90% suppression level across all simulation years with hot and dry climate. I mean, that's a question for people who figure out costs for helicopters and shot crews and all that stuff. I mean, I could calculate a number for you based on the number of acres of fire, but you'd have to give me the input number in terms of what it would actually take in terms of effort to keep those 10% of fires from burning, a majority of the simulation area in some cases, or from burning, a large amount of the burned area as crown fire. The effort would be in fuels treatments or in a prescribed fire rotation that would more closely mimic natural fire. And so again, that's something an out-of-box that we could play with. I wouldn't make a suppression level the response variable. I would make some other ecological attribute or fire attribute the output variable. But I mean, I want to emphasize again that in terms of these out-of-the-box treatments for these landscapes, I mean, I will make up numbers and scenarios and explore these questions. If you give me questions that you have, I'll be one step further to designing scenarios to try to address them. Like, Sue asked a question, are we going to do more, better, sooner scenarios? And that's something that we could do for out of the box is say, if you send me a priority question that's, how much do we have to treat at what interval to achieve X? I am delighted to make that one of the scenarios. If you send me a question that says, to achieve 90% suppression and, only 10% of the area burned in dry forest is crown fire, what do you have to do? That's another sort of that's another question that we can explore with these out-of-the-box scenarios. And then the other way to do it is to just turn that on its head and say, yeah, I want you to model, I want to do exactly what I'm doing now, but with 10 times the intensity, and that's my out-of-the-box. Or I want to do exactly what I'm doing now in the lower elevation forest, but in the upper elevation forest, I want to, thin and burn and increase my, early successional stage, more fire-resistant forest. So those are the kind of things that we absolutely want to be able to help explore with your help with this modeling.
So maybe that's a good transition. I want to quickly wrap up here. Andy, do you want to say anything in closing? And I'll also point people to Will, put his email and phone number in the chat window. Questions, comments, future follow-up, you can reach directly out to Will or Andy. I don't know if you have other avenues.
Yeah, so on the one-pager handout that everyone should have gotten, on the back was contact information for myself, Rachel, Will, and Xander. So please feel free to talk to any of us, and if we're not the right person, we can point you to the right person. And I'm happy if you want to just funnel through me as well, and I can make sure that things get to the right people in addition. I just want to say the things that I've heard from different kinds of scenarios that we might want to be thinking about. Buzzwords that were stuck out there included things like strategic placements, which some things we can and cannot do in the model, so we might be talking to you about some of these things. Focus on treatments, on promoting lower elevation species that are already in higher elevation types. Increase mechanical treatments in the WUI and across the landscape, maybe going to 6 times area burned with prescribed fire and mechanical. More, better, sooner, and how much do we have to treat to achieve a certain thing, and knowing what those certain things are would be really helpful. So we're really hoping we can come back to you all on this, maybe in small groups, or we can drive up there to those Kaibab and get a couple of you at the table and go through what we maybe should be doing for some of these next models and some of these out of the box. We didn't get to talking about these big kind of crazy ideas that are out there, things like bringing up assisted migration in areas that we might do, or clear cutting large fuel breaks. So getting really out of the box on some of those things, and we'd like to have some ideas on what people would like to see modeled or thought about just in the backs of their heads kind of thing. That's all I have. I don't know, any other comments from the peanut gallery?
Well, I want to thank everybody for taking the time to participate, and we as a team, the FireCLIME team, will follow up, and we need to reach to other folks. So if there are people who you think would have good input for this sort of effort, other managers please let us know, and we'll try to keep you in the loop, not burden you with too much communication, but kind of share with you future results, things like these maybe expanded out-of-the-box scenarios. So unless anybody has anything else, I think we'll try to wrap it up here. Okay, well, thanks, everybody. Have a great rest of the day.
Thank you.
Take care, everyone. Bye.